So the purpose of this video is to take a look at the first part of the review for your second test on financial math. This is a practice test that I made up, and I want to take a look at these problems. And before I get started, I wanted to show you what I did for each problem. I highlighted what type of problem it was and what we're looking for in yellow. So for the first one, this is a simple interest problem, and I'm looking for the amount of interest. I wrote down the formula for this particular problem and I highlighted in pink all of the values that will go into the formula. I put over here what section that this particular problem came from, and I did this for all of the problems. You'll see what I mean. So solving this problem, looking for interest, simple interest, my principal in the account is $7,500. My interest rate is 8% or 0.08. Have to convert that to a decimal, and I'm going to let that sit in the bank for 3 years. When I multiply all three values together, I get $1,800 for the amount of interest that was owed. So there's how you do the first one. The second one, let's highlight in yellow what I'm looking for. This is a simple interest problem. I'm trying to find the total amount. This is out of section 2.1. The total amount is $2,500. The interest rate is 12% or 0.1. I'm going to leave it in the bank for 2 years. I am going to say 2,500. 0.12 times 2 is 0.24. I'm going to add that to 1. When I multiply those two values together, the total amount in the account under those conditions is going to be $3,100. So I started with 2,500. Under the conditions, I ended with 3,100. Number 3, what is the amount? There is that formula. How much interest? There is that formula. These are both simple interest problems in pink. In go the numbers. Principal I'm starting with is $7,200. The interest rate is 12% or 0.5. So I have 7,200 times 1.60. That would be $11,520. There is the total amount that I have in the account under those conditions. The portion of it that it is interest is 7,200, 0.12. I'm going to let the money sit in the bank for 5 years. When I multiply those two numbers together, we'll get $4,320. So there's how much I have to pay. This was a loan problem. $4,320 was extra interest. So there's what you would have for number 3, that simple interest problem. Going on to number 4, we're going to head to number 12 on this video. Defining the problem, simple interest, how many years, that's what I'm looking for. This is out of section 2.1. So how many years? I am solving this equation for t. The interest rate is 0.032. The principal that I'm starting out with is $5,000. Now the amount of money, my interest that I have, I went from $5,000 to $6,500. I have $1,500. So there are all of my values into the formula. So $1,500, all of this multiplied is going to give me 160 times t. Now, to solve this equation for t, I'm going to divide both sides by 160. Those two cancel out. I get that. I get 9.3 years, or 9.4 years, for about 9 years. Now, where everybody struggles with this problem, they think the amount of interest is $6,500. The amount of interest you earned was from 5,000 to 6,500. It's 1,500. I got that by subtracting these two values. So if there is a mistake that's made, that's where it is. Problem like that. Now, for number 5, let's take a look at this one. We've moved on to section 2.4. These are compound interest problems, and I'm trying to find the future amount. So I have this formula. The formula's changed, and what we're going to do is basically the same thing, except the formula's changed, and we have a few more numbers that we have to put in. I'm starting with $4,400 in an account. The interest rate is 6.06, and here's one of the new values that I have to plug in, the number of compounds annually. Semi-annually is 2, and that n also is part of the exponent. I'm going to leave all of the money sit in the account for 10 years. So there are all of my values plugged into the correct formula. Let me clean these numbers in this formula up a little bit. 1 plus 0.06 divided by 2 is 1.03. 2 times 10 is 20. Coming up here, my future amount is 4,400. 1.03 raised to the 20th power. That's what you have to get out of your calculator using your exponent key. This is 1.8061. My future amount under these conditions is 7946.84. So my answer for this one would be choice D. I was off a nickel because of rounding. All of your choices will be far enough where you'll see the answer right away. Always pick the one closest to what you solved for. Now, let's take a look at number 6. Compounded. Find the total amount. There is my formula. Same exact problem. This time I'm going to start off with $9,000. 1 plus my interest rate is 10%, 0.10, compounded annually. N is 1, and I'm going to let this money sit in the bank for 16 years. So there are all of my values into the formula. Cleaning this up a little bit algebraically, 1.10 raised to the 16th power. So my future amount is 9,000. 1.10 raised to the 16th power is 4.595. My future amount is $41,355. My answer is D. Now, because of that high interest rate, I turned 9,000 into 41,000. 10% will get you a lot of money pretty quickly. I'm going to turn a little pile into a big pile of money fairly quickly and substantially at 10% interest. Next problem, number 7, sort of the same problem. Find the total amount. Compounded problem. Compound interest. Starting out with $2,500. My interest rate is 16%. The number of compounds I have is 4 quarterly compounds. 4 quarters in a dollar, 4 quarters in a football game. Quarterly means 4. And I'm going to let this money sit in the bank for 6 years. There are all my numbers in that formula under these conditions. 2,500.16 divided by 4 is 0.04 raised to the 24th power. So 1.04 raised to the 24th. My future amount is 2,500 times 2.5633. My future amount is $6,408.25. My answer for this one would be choice B. I was off by a penny. rounding a little bit. That was also out of section 2.4. Number 8 is out of section 2.5. We have a compound problem, interest problem. We want to figure out how much the uncle needs to invest today for his niece to have a certain goal of the amount of money. The goal is for the niece to have $9,000 in the future. There's a certain amount of money that needs to be put in the bank today to make that goal a reality. The interest rate is 10%, 0.10, compounded semi-annually, and the uncle deposited the money in the bank on the niece's 10th birthday. He has access to the money when she turns 18, so the money's going to sit in the bank for 8 years. So this account was opened when the niece was 10. She gets it when she's 18. The money will sit in the bank for 8 years. So 0.10 divided by 2 plus 1 is 1.05 raised to the 16th power. So I have $9,000 is equal to P. 1.05 raised to the 16th is 2.1829. I'm going to divide that 2.1829 by both sides. What that's going to allow us to do is to cancel that out and get the p-value today. What the uncle needs to go to the bank with today is 4122.77. My answer is choice B. So there's what you would have for number 8. Going out to question 12, let's take a look at number 9. Number 9, in yellow, what is the effective interest rate? Giving a nominal rate of 12%, and it's compounded monthly. Now, for this conversion, remember, your conversion formula for effective interest rate is this formula right here, where t is always equal to 1. The nominal rate will get converted to an effective rate using this formula. So I have a 12% named interest rate. It was compounded monthly, and my t is always going to be 1 year. So there are my numbers into that conversion formula. Scooting up here, this is going to be 1.01, 0.12 divided by 12 plus 1, raised to the 12th power, minus 1. So what I have, this value is 1.1268 minus 1. That's going to give me 0.1268. I have to move the decimal over 2 places, and that is going to give me an effective rate of about 12.7%, 12.68%. I rounded it. My answer is choice A. So that conversion formula was out of section 2.5. Here's where it all gets started. You plug in the numbers, and the effective interest rate will fall right out. Number 10. What is the most important variable in determining where you want to put your money to earn the most interest? The interest rate is huge. That determines a lot in terms of how much money you can earn. Number 11, which loan amount will give you a lower monthly payment? 30-year loan. You're paying less each month because your loan is spread out over a longer period of time. So a lower monthly payment, you get a 30-year loan that will help you out. The downside, if you pay a higher amount of interest and a total amount paid on a loan, that would occur on a 20-year loan. You're borrowing the money for a longer period of time. That's going to cause you to pay a larger amount of interest and a higher amount of total on the loan.